After completing this lesson, you will be able to explain what retrieval-augmented generation is, compare the strengths and weaknesses of retrieval-augmented generation versus fine-tuning, make informed decisions about which approach to use, design hybrid systems that combine both approaches. Retrieval-augmented generation is the easiest and most common way to bring private knowledge into a language model. Many of you probably didn't fine-tune any model before, but you almost definitely have tried to build retrieval-augmented generation before, because it is the easiest way to bring new knowledge to large language models. Instead of changing the model, retrieval-augmented generation adds context to your prompts. 1. Turn your knowledge into a vector database. PDFs, websites, documents, embeddings, vector database 2. Retrieve relevant information based on user query. User asks, what's our company's leave policy? System searches. Find most relevant policy documents. 3. Append context to the prompt. Context, retrieved policy documents. User question, what's our company's leave policy? Answer based on the context provided above. 4. LLM generates answer using the retrieved context. Aspect, retrieval-augmented generation. Fine-tuning, teaching durasin. Changes model, no, yes, model weights. Knowledge updates, easy, update database. Hard, retrain needed. Setup complexity, low, medium, high. Real-time data, yes, no. Specialized behavior, limited, excellent. Personality, style, inconsistent, consistent. Explainability, concise sources, black box. Cost, API calls, training cost. Latency, retrieval adds latency, just inference, byte image. News chatbot, articles added daily. Product documentation, features updated weekly. Legal research, new cases and laws, financial data, stock prices, market updates. In most cases, retrieval-augmented generation is actually the default option you should go for. With retrieval-augmented generation, it's much easier for you to update the knowledge base and even bring real-time data into the prompt. Research assistant must cite papers, medical advice, need to reference studies, legal advice, must cite cases and statutes, customer support, link to knowledge base articles. Enterprise documentation, thousands of documents, Wikipedia-style applications, constantly updated, customer database queries, real-time data. Data must stay in your infrastructure. Can't train models on sensitive data. Need audit trails of what information was used. Medical image analysis, specific diagnostic patterns, legal argument structure, jurisdiction-specific reasoning, code generation, company coding standards, creative output, ASCII art, specific art styles. If you found the base model struggling to complete specialized tasks in your domain, or to play with different prompting tactics, and it doesn't work, then fine-tuning is a great option for you to try out. AI companion with personality, sarcastic, funny, formal, celebrity-style mimicry, write like Paul Graham, Hemingway, etc. Brand voice consistency, specific tone and style. If you're building an AI companion or trying to mimic the way certain celebrities speak, like being sarcastic or a bit rude, where default models simply won't have that, and you can prompt it to maybe 80%. But to get really high fidelity of mimicking the way someone speaks, you actually want to fine-tune it. Always output valid. JSON, critical for production systems, specific format adherence, SQL queries, API calls, consistent formatting, reports, summaries. High volume applications, thousands of daily requests, replace expensive API, GPT-4, fine-tuned, Llama 3 8B, on-premise deployment, no per token costs. What is beautiful? For ASCII art or creative tasks. What is funny? Can't instruct humor effectively. Subtle style elements. Only demonstrations work. For certain behavior, it's actually very hard to write a good prompt. For example, Let's say you want an LLM to draw beautiful ASCII art. Well, just try to write an instruction about what beautiful is. You will see that's almost impossible. Same with, for example, instructing an LLM to be funny. If you do that, the LLM won't be funny at all. In my opinion, the most interesting thing is if you would combine retrieval augmented generation together with fine tuning. You could then use retrieval augmented generation to accommodate that the knowledge base is frequently changing, and use fine tuning to make the model learn domain specific terms, to make it refuse certain questions, to fine tune on wrongly answered questions so that the performance actually improves over time. Retrieval augmented generation handles dynamic, changing knowledge, real-time information, easy updates, fine-tuning handles, domain-specific reasoning, consistent personality, tone, structured output format, specialized behavior. Benefits: up-to-date information, retrieval augmented generation, consistent brand voice, fine-tuning, proper escalation logic, fine-tuning, cite sources, retrieval augmented generation, fallback when retrieval fails, fine-tuned knowledge. Let's apply the framework to 5 scenarios. Knowledge changes: daily, news articles; behavior, standard Q&A; decision, retrieval augmented generation; reasoning, news updates constantly; fine-tuning would be outdated immediately. Knowledge changes: his essays are static; behavior, specific writing style; decision, fine-tuning; reasoning, teaching subtle writing style; hard to prompt, demonstrations work better. Knowledge changes: some docs update, some static; behavior, standard search; decision, retrieval, augmented generation; reasoning, primary need is access to changing docs. Citations important. Knowledge changes, laws change, but not daily. Behavior, very specialized legal reasoning. Decision, hybrid. Reasoning, retrieval. Augmented generation for latest case law. Fine-tuning for specialized legal reasoning and contract structure. Knowledge changes: a PI schema is stable. Behavior, must always output valid JSON. Decision, fine-tuning, reasoning, structured output reliability is critical. Fine-tuning achieves 99% plus valid JSON. 1. Retrieval augmented generation is easier to start with. Try retrieval augmented generation first for most knowledge tasks. 2. Fine-tuning is for behavior. When prompting doesn't cut it, fine-tune 3. Hybrid is powerful. Best of both worlds for complex applications 4. Time horizon matters. Changes daily. Retrieval augmented generation. Static knowledge. Consider fine-tuning. 5. Quality matters. Retrieval augmented generation depends on retrieval quality. Fine-tuning depends on training data quality. For each scenario, decide: retrieval augmented generation, fine-tuning, or hybrid. 1. Restaurant recommendation chatbot. Needs up-to-date restaurant info, hours, menu, reviews. Should have friendly, local personality answer. Hybrid, retrieval augmented generation for restaurant data, changes frequently, fine-tuning for consistent friendly personality and local knowledge. 2. SQL query. Generator from natural language. Convert English to SQL queries. Database schema is fixed. Answer, fine-tuning, structured output, SQL, specialized task, schema is static. Could use retrieval augmented generation if schema documentation is large and complex. 3. Academic paper Q&A. Answer questions about uploaded research papers. Papers don't change once uploaded. Answer retrieval augmented generation, dynamic knowledge base, new papers added, need citations, standard Q&A behavior. Base model sufficient. 4. Medical coding assistant. Convert diagnoses to ICD-10 codes. ICD-10 codes update annually, requires understanding of medical terminology. Answer hybrid, retrieval augmented generation for latest ICD-10 updates and lookups, fine-tuning for medical terminology understanding and reasoning. 5. Poet in Shakespeare's style, generates sonnets like Shakespeare, historical data, fixed. Answer, fine-tuning, creative style transfer, behaviour hard to prompt clearly. Fixed training corpus, Shakespeare's works. Based on what you've learned, refine your project idea from Lesson 1.1. Answer these questions. 1. What knowledge or capability do you want to add? 2. Does this knowledge change frequently? How often? 3. Is the primary goal knowledge, facts, or behaviour, style, task? 4. Based on the decision framework, should you use retrieval augmented generation, fine-tuning, or hybrid? 5. Why did you make this decision? Example. Answer. Keep your answers. This will guide your Module 7 project. 1. Retrieval augmented generation is for dynamic knowledge, easy updates, citations, explainability. 2. Fine-tuning is for behaviour, personality, specialised tasks, consistent style. 3. Hybrid combined strengths, dynamic knowledge plus specialised behaviour. 4. Start simple. Try retrieval. Augmented generation first, add fine-tuning if needed. 5. Knowledge versus behaviour. This is the key distinction to remember. Now that you can decide between retrieval augmented generation and fine-tuning, let's understand how models are actually trained. Lesson 1.3, how large language models are trained. Still unsure about your use case? That's normal. As you learn more about fine-tuning in the next lessons, your decision may become clearer.